Hello guys, I welcome you all. If you want to learn how to model Spur Gear in SolidWorks, then you have come to the right place. We will learn modeling Spur Gear using Involute profile. So we will start our sketch in the front plane. Okay. We will use equations to define the different dimensions and we will use pitch circle for the basic parameter on which all the calculations will be based. Before getting started with the sketches, we will define some relations and some equations which will help us in our further sketching. I will go to tools and I will select equations. Now I will add a global variable. So for pitch circle, I will write dp, enter, and I will give it value 100, enter. Okay, now comments I will write pitch circle diameter. Now I will add another global variable theta. Now I will give it 20 degree. Now theta is the pressure angle. Okay. Now I will define another global variable. I will say it base diameter. Now in order to define the diameter, base circle diameter, we will define an equation. So base circle diameter is equals to this equation you can see, where r is the radius of the pitch circle and cos theta is the cosine of pressure angle. So here I will write it dp multiplied by cos of theta. Okay. Now I will define circular pitch, capital P. I will make it equals to 0.25. Okay. Now this is equals to circular pitch. Now addendum A. Now addendum is equals to 1 over P. Okay, I will have to put quotation marks here. Okay. Addendum. Now I will define the addendum with B. The addendum is equals to 1.25 over circular pitch. Hit enter. Now I will click OK. Now here I will start our sketch in front plane. I will draw a circle. Now this is a addendum circle. This will be equals to pitch diameter minus 2 times addendum. Click OK. Select. Extrude it up to 10 mm. Click OK. Now I will select the face and I will sketch on it. Make it normal. Now I will have to draw 3 circles. Base circle, pitch circle, a random circle. Okay. Now make all the circle for construction except. Now dimension it. This will be equals to simply base circle. Okay. Now you can see this is not an equation. This is the dimension. But I want it to be equation, so I will have to write it like equals to, and then I will have to give the variable name. Okay. Now you can see the equation sign is being shown here. Similarly, for the pitch circle equals dp, hit enter. Okay. For random, this will be equals to pitch diameter plus 2 times random. Okay. Accept. Now we will draw the involute profile on the base circle. I will draw a center line. I will draw 6 center line, but make sure all these center lines are being coincident on the base circle. One more. Now join these center lines like this. Okay. Now make all these lines equal. Okay, we have to draw one more center line. Accept it. Also make it equal. Now you can see all these lines are equal. Now draw lines like this. Now delete this equal relation. Okay. Okay. Now we have to give it some dimension. Now make this line and this line equal. Okay. Now make it equals 4 mm. Okay. Or let us make this equation equals, let us define it R. Make it global very equal. Okay. Now it is an equation. Now make it equals to 2 times of R. Okay. Now make it equals to 3 times of r. Okay. Make it equal to 5 times of r. Sorry, it will be 6 times. Okay, now you can change all the dimensions by changing only one value. For example, I will make it 5. Now you can see all the dimensions has been changed. That is the reason we make it a equation. We will make it 4. Now make this line and this circle tangent. Okay. Similarly make this line, this circle tangent. Make this line, this circle tangent. Okay. Make this line, this circle tangent. Okay. Now make this line and this circle tangent. You can see our last line is not passing from the addendum circle. So we will change the dimension here. We will make it 5. So it is okay. So now you can see the point is above the addendum circle. So now it is okay. Now we will select spline and we will connect these points. Okay. Now this is the half side of the spur involute. We will also have to make the other half, but we will make it from using mirror entities command. Now for that we have to define the distance. In order to define the distance, we must know the circular pitch of the gear. The circular pitch of the gear can be defined using the equation. Now you can see that circular pitch small p multiplied by pitch circle, which is capital P, is equals to pi. Now by using this relation we can find the circular pitch, which is equals to 4 pi. Now circular pitch, you can see from here, circular pitch is the distance from here to here. You can see this. Now if we make it half, in our case which will be 2 pi will be the tooth thickness. Now if we further make it half, it will be the half tooth thickness, which will be equals to pi for our case. So we will be using the same principle and we will find the angle for the pi arc length. Now it is very simple to find the theta if arc length and radius is given. Radius is equals to 50 mm, which is the half of the pitch diameter, and s, which is equals to pi. Now we know the relation s is equals to r theta. Now we will put the values. Pi is equals to 50 multiplied by theta, pi over 50. Now this angle is in radians. We will convert it in degrees by multiplying it with 180 by pi degrees. So it will be 3.6 degrees. So we will draw a line like this. Make sure it is coincident with the pitch circle. Now we will draw another line like this and actually make it fix. Make it fix. Okay. You delete the coincident relation. Now it is okay. Now define the angle of this line and this line 3.6 degrees. Okay. Now make this spline and this fixed line coincident. Okay. Now you can see the spline is also fully defined. Now we have to mirror this spline about this line, which is highlighting this line. Okay, we will select mirror entities. Entities to mirror, we will select the spline and mirror about this. Okay. Now trim the upper part. Okay. Now select center line and draw a radial line from center to the spline here. Okay. Now select a 3-point arc and draw a 3-point arc here like this. Make sure it is coincident with the random circle. Now select convert entities command and select this circle edge. Accept it. Now it has been converted. Okay. Now select line and draw a line from spline to the circle and chain. Similarly, draw another line. Make sure it is coincident with the circle edge. Okay. Now using trim command, trim this extra circle. We don't want this. Okay. Now our sketch is ready to extrude. Now go to features, extrude. Now extrude it up to the surface. Select this surface. Accept it. Now you can see one tooth has been generated. Now go to circular pattern and select this feature, direction, select this edge. Now number of teeth can be found using diametral pitch. Now teeth on the gear is equals to diametral pitch multiplied by pitch diameter. So in our case it comes 25. So we will make 25 teeth on the gear. Accept it. Now you can see our spur gear is formed.